Excellent. You've made it. Hello, minions. It is I, Monaco. Shout out to Milks. This one sips for you, buddy. Lecture 3 in Physical Behavior of Matter. We're going to talk about types of energy, heat, and temperature. You are going to know how to tell me about heat transfer at the end of this lesson. And you're also going to be able to determine temperatures in Kelvin and Celsius, convert temperature after this lesson. Okay, so let's get into the meat and potatoes. First things we're going to talk about is the types of kinetic energy. Kinetic energy is the energy of motion, and heat causes the particles to move. Okay, so heat and kinetic energy are directly related. Heat causes particles to move. There are three basic types of kinetic energy motion. Okay, there's vibrational motion. All atoms are doing this in the universe, vibrating in place. If it's a solid, they're stuck. If it's a liquid, they're rolling past. And if it's a gas, they're moving in straight lines, but they're still vibrating at the same time. That's what that means. Bobbling without spinning. Translational, moving from point A to point B. Only liquids and gases can do this in their phases of matter, because solids are stuck in crystal structures usually. But it's moving from point A to point B. And then there's the rotational motion. So liquids and gases can do this because their atoms are vibrating and rotating past each other, but solids can't really rotate past each other. So there we go, spinning around an axis. That's what rotational motion is. Now, potential energy. Kinetic and potential are related. As kinetic energy goes up, potential energy goes down. Kinetic energy is motion and moving. The faster you move, the more kinetic energy you've got. The potential energy is motion or energy of position, so how much you could do. So the slower you go or the higher you go on this particular scale here, the more potential energy you have until you stop. So kinetic and potential energy are interchangeable. Kinetic can turn into potential and potential can turn into kinetic, but you can't have both at the same time, which is the key underlying factor to a later lesson. Okay? It's energy of position or stored energy. It relates to phase change only. That's the later lesson that I'm talking about. So heat versus temperature. A lot of people think they're the same thing because when it's cold in the house, you say turn up the heat and the temperature rises. Why wouldn't you think they're the same thing? Well, heat is actually the energy that causes particles to move. It is kinetic energy. It causes kinetic energy to happen in atoms. Temperature is the measure of that kinetic energy. So when you put a thermometer into something, it's measuring how fast the particles are moving. Ooh, this one's kind of hot. Okay. It doesn't actually measure the heat, though. It just measures how quickly the particles are moving. So there is a distinction, a difference. Heat always flows in one direction only. It can't go in reverse. It goes from hot to cold. So high concentration of heat will flow to low concentration of heat. You felt this every time you put your hand over a hot plate on the stove to see is it ready to put food in it, because the hot plate radiates heat out to the cold environment and atmosphere, and you can feel it. So heat goes from high concentration to low all the time. Absolute zero. Well, there's three temperature scales: Kelvin, Celsius, and Fahrenheit. Fahrenheit, garbage units. We don't like to use them in chemistry. Celsius, great units. We love to use them in chemistry because it's based on 0 degrees Celsius is the freezing point of water, and 100 Celsius is the boiling point of water. Kelvin's the new scale. Kelvin is an absolute scale, okay? And it's based on the motion of particles. And theoretically, 0 Kelvin is where there's no motion, no vibrational, no translational, no rotational energy. We haven't achieved this, so it's only a theory. Now, the scale covers total energy. It's not limited to that melting and boiling point of water. So it considers the total amount of heat, and we'll use Kelvin when we do heat calculations later on. How is temperature and kinetic energy related? Well, heat is energy, specifically kinetic. I'm starting to repeat myself now because it's important. Okay. Now, temperature is the measure of average kinetic energy. Therefore, temperature is measuring heat indirectly. To convert between temperatures is not a hard thing to do. You have to apply this equation. So we're going to do some conversions, and I'll show you how to plug and chug it up. See, I'm going to do 0 Celsius first. I'm going to the board. So to do 0 Celsius, you just start with your equation. Kelvin equals 0 degrees Celsius plus 273. And you're going to solve for Kelvin in this case. So, I forgot my 3. I'm going to subtract, well, I guess I already did it. 0 plus 273. So 0 Celsius equals 273 Kelvin. Okay, that's a pretty easy, pretty straightforward one. 0 Celsius equals 273. Let's check out our next one. 100 Celsius. Well, this time we'll use the same equation, same plug and chug. Kelvin equals 100 Celsius plus 273. Well, that means the Kelvin equals 373 Kelvin. And this is a good point to make the point that 1 Kelvin degree is the same size as a Celsius degree. They just start at different points on the scale. So the size of a degree in Kelvin and Celsius is the same, but they start at different points, which is why there's no negative temperatures for Kelvin. A very useful thing when we do our heat calculations later on in life. Last one we're going to do, negative 273. So we're going to do Kelvin equals negative 273 degrees Celsius plus 273, and therefore the Kelvin equals 0 in that case. Converting Celsius to Kelvin is very easy. You just always add 273 to your Celsius value. Converting Kelvin to Celsius backwards is going to be subtraction. We're always going to subtract 273 away from whatever Kelvin we're given, and they'll tell us our Celsius number. So let's see. 273 Kelvin. I'm going to set the equation up the same way. It's just that the numbers are going to be different spots. So 273 Kelvin equals degrees Celsius plus 273. So to solve for Celsius by itself, I'm going to take 273 away from each side. And therefore, this drops out. That turns to 0. So let's see. Plus minus 273 is 273 equals 0 degrees Celsius. That's the part that's messing me up. So 273 Kelvin equals 0 degrees Celsius. Sorry, my math brain wasn't working too well this morning. That's why I need milks around sometimes. Let's get 373. So 373 Kelvin. I'm going to convert that to Celsius. 373 Kelvin equals degrees Celsius plus 273. So I take 273 away from each side. 73. And I'm left with 100 Kelvin equals the degrees Celsius. Well, Kelvin drops out. So degrees Celsius equals 100. And then the last one we're going to do. There isn't one. There is no last one that we're going to do. Okay. So convert Celsius to Kelvin. Celsius to Kelvin, very easy using the equation. Heat is not the same as temperature. Heat causes particles to move, and temperature measures the motion of that particle. Okay, that is your lecture. Thanks. See you later. See if I can find this button and click the video off. Yeah.